Right, I think it's time to get started. Everybody hear me okay? Good morning, guys. Good morning. Thank you very much for showing up today. I know it's second last day of the conference. People are getting tired, looking forward to go home. I'm looking forward to go home as well. But, well, let's make your time here worth today. My name is Narayan. I'm a program manager in Azure Networking. I'm joined by my colleague Sumit Mittal. Both of us will talk to you today about Private Link. The doors are going to be closed, guys. Everything here is private. There's no more public stuff. So if you want to leave, here's the last chance. If you choose to stay, then you'll be thrilled. I can tell you that much. So last year we came to the conference and we had a lot of networking sessions and content and a lot of familiar faces over here. I'm glad to see. And the topmost ask from you guys was to say, allow your PaaS services, but bring them private to me. I don't want to go over the public internet or public IP address. I just want to consume PaaS privately in my VNet. That is what we've been working on, and today we're happy to kind of announce that to you. We did a public preview announcement like a month and a half, but this is the first time we're seeing you face to face, and want to take the opportunity to kind of show you what it is. All right, with that, the agenda for today is at the end of the session, you will know what Private Link is, how to use it, how to do a demo, a cool demo for somebody who wants to know about it, and how to go and make your PaaS services more secure as you go back to your desks Monday morning. So that's the goal here. So before I start too much, this is a 300 level session, so it's not working. I just realized that. Do we switch it? Which one do we switch it to? It's working here, but not over there. Oh, it was frozen. It was frozen. I had to like click on the frozen button. Now it is. It's good now. All right. Anyways, we didn't miss much. No worries. So it's a 300 level content. So I'm not going to go over a lot of basics. So I kind of assume and hope you know about VNet, subnet, what is the NIC, how a load balancer works in Azure, security groups, express route. Because if I talk about those, that will be 1 hour, and I won't talk about Private Link. So I'm going to assume that you all know that. So we'll move ahead. Okay, so before we really get into Private Link, let's go back and see what do we have today that you've been using to secure your storage accounts, right? And let's see what was good over there, what was not fully covered yet, and how did we move into the Private Link part. So as you all know, Service Endpoint, I think, has been in GA for like more than 2-3 years now, and that's the tool that you all use to secure your PaaS accounts, like Storage or SQL DB. The way that works is pretty cool. You go to the VNet and enable Service Endpoints, and the traffic then goes via the optimized route over a backbone network. It gets to Storage or SQL, and over there you add ACL to say allowed from this VNet, not from anywhere else. So your storage account is secure, right? So it's good, and a lot of people, you have great adoption. Everybody's using that. However, what is that it doesn't cover still? If you look at the left side, the VNet side, the NSGs over there still has to open up to all of storage, right? It's really not, and the storage account is still a public IP address. You're not really private yet. So you just open up to all of the storage public IPs. So the traffic to storage kind of goes over there. It does carry the extra metadata that is coming from this VNet. And then over there, you're able to lock it down and say, okay, just allow from this particular VNet only, right? If you really want, this may be okay for many people because like instead of talking to the internet, you're only talking to storage is good enough. But if you really want to lock it down to specific accounts, you won't be able to do with this, right? And it doesn't help with on-prem as well because this is all Azure only solution. So that's some of those reasons why you all wanted more than this. You want really private. This is good, but you guys told us, no, we want it really, really private. I want it in my VNet. I just want to look it up and it's a private IP address. So that's what we did. So what Private Link does is it takes those PaaS accounts, whether it is Storage, SQL, or Cosmos DB, and then it maps it into your virtual network as a private IP address. And the way you consume that is now private endpoint. So you create a private endpoint, and that's basically a NIC. And that private endpoint is a map to the specific instance of that PaaS resource. So now, what's the biggest difference? Look at the NSGs right now. Look at the difference between the left side and the right side. The NSG on the right side only allows egress. This is the outbound NSG. Only allows outbound to within your VNet, and internet is denied. I say it's green because that's where you want it. It's a good state to be in. You don't want to talk to internet. You only want to talk within your VNet, and that's what the NSG is telling you, and still you can access the storage account. How is that? Because the VNet is kind of stretches out pretty much and makes it a full private plane for you. So just like how you talk to a VM in your VNet, you're extending that same kind of a concept, same kind of a private boundary over to the PaaS side, right? You're wondering, is it for all storage accounts then? Is entire Azure storage getting mapped into my VNet? Right? There's like thousands and millions of storage accounts. No, right? So we have inbuilt data exfiltration protection. So what we really do is we pick a very specific instance of the storage account, and that's the one that is mapped back to your VNet. So when you create a private endpoint, and I'll show this in the demo, you are picking a very specific storage account, right? It's whatever your account or blob.co.windows.net. It could be .q or table, whatever it is. You pick that specific instance of the PaaS account, and you assign that to the private endpoint. And when the private IP address that gets assigned to the private endpoint is only going to allow you to access that particular storage account. If you try some clever tricks, let's say somebody in your org goes and mucks with this host or text file and says, I'm going to use a different storage account, maybe map it to this private IP address, let me try to send a packet. Nope, our network will drop it. Because the network has intelligence to know that this private IP address is only mapped to the specific instance of the PaaS account, storage account or the Cosmos DB. And if you try to do some other DNS clever tricks or whatnot, it will get dropped. So it is super secure. This is inbuilt data exfiltration protection. So someone in your org, inside the VNet, if they're thinking about like, let's read the data and write it to my personal storage account, they can't do it. Why? Because I showed you the NSG. The NSG is not open to all of storage. The NSG is only open to your VNet. And in your VNet, this is the only storage account that is mapped. The other account is not mapped. So unmapped accounts, no access, right? This is kind of a first. Other cloud providers don't offer such an ability, right? They offer more like I'm mapping a service to a private IP address, the entire service. This one maps a specific instance to the private IP address, right? I do want to take time over here because it's important for you to understand this difference, because that's the security that we are shipping inbuilt as part of private endpoint. Okay. Now we looked at all of the Azure stuff, but what about on-prem? Because most of your data comes from on-prem. You push data to storage or read data from storage, right? Let's look at all the options we had and how the horizon is changing now. So I'm only comparing from a security standpoint the different options that you had. So what do you have? I mean, typically all storage accounts, SQL DB, all of PaaS was accessible over the internet because they all had public IP address, right? If you didn't do anything, that's what will happen. From your corporate HQ or branch offices, you come via the internet, go to the PaaS, right? Yeah, on the PaaS side, you could put an IP ACL. Most of our PaaS services allow an IP ACLing mechanism. So if you really know your NAT IP on your on-premises, you could put that and say only from my on-prem NAT IP and from nobody else. That works, yes. And by the way, you'll get great performance because we have awesome peering on the internet with ISPs. So you're going to get the optimal route to come to Microsoft's public IP address. So this is good from a connectivity standpoint. From a security standpoint, this is good as long as you can do ACLing and you're okay with it, right? But what's a better solution is if you use Express route, then we do have something called Microsoft peering. So with Microsoft peering, we advertise all of the Azure public IPs over to you over the Express route link. And now instead of taking the public internet, you come via this private connection that you have made with us via Express route and then drop down. However, the traffic is still coming addressed to a public IP address, which means you still have to have a public IP ACL, right? It's great as long as you know the NAT IPs, but what I've heard from customers, a new branch or a new HQ comes up or something like that, there's a new NAT IP address that is going to use for internet branch out. Now you have to come and add that IP as well. So constantly you're managing the IP ACLs on this side, which could be challenging, right? So what's the best? If you just use Express route with private peering and private link, right? you're going to come completely private. See how lower down the stack you're getting into with Microsoft's network. So this is like getting you right, private, fully private. So you don't have to enable MS peering. Just from private peering, all of the private IPs advertised to you back on-prem. So this storage account is a private IP address right now. So the private peering sees it or does PGP to you. So you send it, it comes to the gateway, and then it goes via our backbone network, fully private. Look at the right-hand side. There is no more IP ACLing that you need. You just allowed private endpoints, and that's good enough. That's good enough for your previous scenario to come from Azure. That's good enough for you to come from on-premises. Fully private, nothing public. That's how this changes the connectivity from on-premises. So with that, this is the Azure Private Link's entirety. It's not just for PaaS services. Private Link is not just a new feature. It's a new platform ability. With Private Link, we want you to use this platform ability to share your services also privately in Azure. It is not just restricted to our PaaS services. You'll see that Private Link is going to get supported by marketplace services, your own services, right? That's the spectrum. And any Azure public service can be mapped to a private IP address, right, using the private endpoints, and that's the concept. So I'll clarify a few things for you because you're hearing a lot of words. Private link, private endpoint, private link service, what is this? So let me just clarify. So private link is the name of the ability. That's how you connect to Azure services, or rather, services running in Azure privately. That's private link, that's the ability, that's the product. Private endpoint is how you consume it. So when you go to the virtual network, you create a private endpoint to connect to a service that's powered by private link. Now the last part, the service that is powering you through a private link is called a private link service. The private link service can be of three types. It could be our PaaS services. I talked about Storage, SQL DB, Cosmos DB. It could be our partner services, Snowflake and whatnot. You'll hear more about it. Sumit is going to go over that. And third, could be your own service. These are all private link services. You connect to them via the private endpoint, right? I'm going to take a few minutes to maybe show you, if you're thinking how this all works, right? I want to show you a simplified diagram of how it works. But before we go there, this is a very important slide. The reason we are able to give you such powerful features is because we are built on top of one of the best networks in the world. That's our Microsoft WAN, right? So Microsoft WAN connects all data centers privately, it's 8075 network. And this is the same network that connects you to the express route locations or to the ISP peers. So if you look at a data center where Microsoft is, so we have the routers which either take you to express route connectivity with our partners or the public internet connectivity with other ISPs. And in the southbound below that, what you see is it connects it back to a data center network, right? If you see on each region, we have multiple DCs. Under the DCs, we have availability zones. Under the availability zones, we have our what we call as clusters. There's racks of servers. So they are all plugged into this network. So anytime a packet from one of these properties, be it a VM or a blade or full native host machine for us, can talk to something else on this network fully privately. You never have to leave that white line that I've drawn over here. It's called Microsoft's WAN. All of our DCs are interconnected privately, right? This is the ability that's powering services like Private Link to come to life. Now, how does Private Link work under the covers? Did I miss adding content? Oh, under the covers supposed to be black, right? Black magic. No, it's not. So I did try to put some simple slides. So take an example of a VM talking to storage, right? How does it work? And by no means this is how exactly it is. I've simplified it to a level where I can talk to it. So, the VM starts sending a packet, right? The source is its own private IP address. Now with Private Link, the destination is also a private IP address, but it is actually to that particular blob account. It has payload after that. That's how the packet originates from the VM, right? Next step, that packet then drops down to our host. What you see here is our host SDN plus our Microsoft WAN backbone network. When that packet drops, as you see, I retain the green portion of it, which is the private portion. I do add an encapsulation layer to go from what I call as a DIP over the data center IP address. So I have a unique routable IP for this VM, and I'm sending it to another unique routable IP on the storage side. I know that. I know how to route privately to this storage account. I add that as an encap, plus I add some more metadata about which VNet, what private link ID it is, and all that. Packet travels the backbone network, goes to the other side, right? And then we have our host networking doing the processing, doing the decap or whatnot, gives it back to the storage front end that says, here is your green packet, the encapsulation is removed, so the packet got delivered fully privately to the other side. That's how it works, right? So I do have a few minutes to do a quick demo of this. So let me switch to my machine here. Cool. So what I'm going to show you is storage on a VNet. So let's create a new storage account. And you'll see that, and I'm creating a new storage account. Yeah. So you pick all that, resource group. I'm going to say ignite. I have a resource group preset, storage account name, ignite stg3, and come down. I'm okay with those. Networking. Here is what I want to pass, right? Look at that. As you create the storage account, you have an option to create it privately by default. Default it says public, or it says with specific service endpoints. You can log it onto some specific networks, or that option, private endpoint. Now, the minute I say private endpoint, it tells me, okay, tell me which private endpoint, which VNet you really want it in. I add it. I can pick. I'll pick a East US. Give it a name, private endpoint 3, blob. Now the VNet, I have an ignite VNet. I select that. Subnet. Now, I've already pre-created a couple of subnets in this VNet, so it's just asking me to pick one of them. I have an endpoint subnet. I'm good with it. Look at that, integrate with private DNS zone, and I say yes by default. This is super powerful. So what we do here is we register a new domain for this against the CNAME of your storage account. So it's best to leave it as yes, say okay, and off you go. The next button here, advanced, say I'm going to go okay with all those, create. Now the storage account is actually creating right now, the validation is passed. So let's go back. I'm not going to wait for that to fully come up. I'll go back because I already have my storage account created here from last night. So I did the storage account exactly like how I showed you before. And this storage account, as you can see, it's created that way, very same way. Now, if you go look at private endpoint connection, that storage account already has a private endpoint from my VNet that's in approved state, which means that's the only one that can access the storage account. If you go to firewalls and networks, it says that no networks. I selected none, so which means you can access the storage account from anywhere else. Now, to prove that point, if you go back to blob, look at the containers. It says ignite blob I created last night. Look at that. The reason I can't even look at the content of that blob is that I'm connecting to that blob from public internet right now. This laptop is now connected via the whatever network we have here and goes public over the internet. Tries to access the blob, no access. Now, good for us, I already have a VM. So I do want to show that there is a VNet over here, consumer VNet, and sorry, it's an Ignite VNet, 2019 VNet. I do have a VM over there. I just remoted into that VM. This is the VM. I'll show you the IP config. 10024. This is the VM in the VNet. Now, let's do NS lookup of the storage account. I just did this because it's another VM that I have in this VNet. If you do NS lookup on that, I get 10.0.2.5. You know this, right? Because within a VNet, you can look up other VMs, you get a private IP address. Just like that, I'm going to look up the storage account that I just created last night. Look at that, 10.0.1.4. That's the IP address of the storage account, right? You usually get a public IP address. This time around, it's a private IP address. Now, using Storage Explorer, I did connect to that. So here, I could see that that has a blob. I can see it. Okay, I'm adding another new line. Hello, Ignite, private link session. Oh, see, what a great formatting there. Just to allow Ignite, I'll upload this, save it. Did not. Let me see. Okay, upload. From this VNet, I'm kind of uploading that. Okay, it's asking me multiple times. It's okay, but it's all upload is all done. I have another VM, this VNet. Okay, which as you can see here, we do NS lookup of that. This is also on the VNets, it's able to see it. So let's go to the storage blob from this VNet. Let me see if I can see the content. Ignite blob. Upload word. From here I can access it. That's it. The new line I just added, you're able to see it over here. This storage account, guys, right now is only accessible from the VNet and from nowhere else. I'm going to go back to the main screen. Is it 6? Which one? 5? Okay, cool. I'm almost done with that. So a few announcements I wanted to make. So as of today, as of yesterday actually, as of Monday. So we have preview in all regions for storage, SQL DB, and you bring your own service. You can try it on any region. It's in preview. We'll soon GA that. And for Cosmos DB, we are announcing a preview in a couple of regions, or 2 or 3 regions that you can see there. We are working on releasing this to all regions, GAing that and all that. Sumit is going to come up and talk about the other scenarios that Private Link offers and the roadmap. Thank you.
So, hello. Yeah. Okay. Good morning, folks. And thank you, Ryan, for walking us through all this great stuff. So, if you have seen, Ryan mostly talk about consuming PaaS, right, and all the benefits that Private Link brings for consuming PaaS privately, right? So we can access PaaS privately from on-prem. We get inbuilt data exfiltration protection and many other good benefits from Private Link. But what I'm gonna do is I wanna move you through another possibility using Private Link. So when you get out of this door today, right, remember that Private Link can be used not only to consume PaaS privately, but also your own services that you can map privately into your VNets. It can also be used to consume other marketplace services, right, into the customer's VNets, right? So it is that powerful. With that, let's start. So Azure Private Link, right? So it helps you render and consume services privately on Azure. When I say render, so you can be a service provider. The persona is service provider. And you can create a Private Link service, right? And when I say consume, so you can be a service consumer. The persona is service consumer, and you have to use a private endpoint as a resource. Okay, so let's see what I mean by your own service, right? So the beauty of it is you don't have to always create a new Private Link service, right? So if you have any existing service that you're running, right? So that you can, with a click of a button, with one API call, you can convert it into a privately linkable service. So it enables VNet to VNet connectivity, without worrying anything about the overlapping IP space. We are going to touch this point again, like down the slides. And another empowering thing is like with this private link technology, you don't have any regional or tenant subscription or back restrictions that you used to have with many other like services or like features earlier. You can easily scale and manage your service. We will see how. So let's see like what it entails to create a private link service. Let's say like you have like bunch of VMs running behind a standard load balancer. This is the most common scenario that we see. That's why like we tie the private link service to the standard load balancer. All you do is just make one API call, or like you just click a button on the portal and it will convert this service to a privately linkable service. Isn't that simple? Right? So private link service is tied to the front-end IP of the standard load balancer. This is a very important point, right? The IP, the front-end IP configuration can be both private or public. So if you're running a public service, you can make it a privately linkable service, or you can have a completely private service that you can spin up brand new. Okay, so let's see how we can consume this service. So on the other part of on the other part, you have consumers who have some virtual network. So what they can do is similar to consumption of PaaS. The consumption experience is very similar. So you create a private endpoint, right? You kind of attach it to some sort of identification that you get from the service provider, and boom, you're connected. The goodness is like many different consumers can connect to the same service, and you don't have to have like all the right RBAC permissions and stuff. We will see how. Right, so when we talk about marketplace scenarios, right, so when it's a very common scenario where the marketplace vendor will want like its consumers to come from like different spheres, right? They will have all different, they will belong to different AD tenants, they will have like, they will belong to different geographies. So we want to take away all these limitations. So let's see how this is done. So I'm going to walk you through a simple call flow. So you have service consumer on one side and you have a service provider on the other side. What service provider does is create his service or use an existing service, spin up a private link service on top of it, convert the service to a private linkable service. When you do that, it will generate some sort of identification for the service, right? So it can be either the complete resource GUID that you are like used to using, or it can be something called alias that we will talk a little bit later. You can pass on that thing to your consumers. So your consumers will use that and create a private endpoint. So as soon as they create this private endpoint, a request will be sent to the service provider. Optionally, I mean, on the consumption side, as Ryan mentioned with the PaaS, right, you can configure your DNS settings so that you are using the same applications with the same connection strings the way you were using, but pointing it to the private IP of the private endpoint. And on the service provider side, you will get all the requests from all the consumers, right? So you have the ability to either approve it or deny it. Once you approve it, the connection is established and the private link is established. Is that simple enough? Right? So this is how the complete picture will look like. You have the consumer towards the left and the service provider towards the right. As you can see, once the link is established, we suck up all the traffic and all the traffic stays on our like powerful Microsoft network. It never leaves to internet. The connectivity is completely private. Okay, but the thing is, one thing that is good about our partners and customer is they never let us settle for less. And they're right in doing so, right? So they have been demanding like some capabilities that empowers them for running their businesses on private link or like using their own customer-owned scenarios. So these are some of the key capabilities that I want to walk you through. Very first is something called alias. Now we have been talking about privacy, right? Security. So what if the service provider has to share his complete resource GUID with the customers, right? Think of a scenario, marketplace scenario, where like somebody is sharing his complete resource GUID with like tens of hundreds of like customers. Then the service provider is basically sharing his subscription information, his resource group information, so that the whole element of security and privacy is compromised, right? So nobody wants that. So to mask that, what we have done is we have created something called alias. It masks all that information and creates you a unique name, which is like readable, right? And which you can share. We map it on the backend, right? So now the next question, right? So how can I ensure like two service providers are not using the same alias? Because we make it unique. The alias is a globally unique name, right? We get some portion from you as your service name, and then we put some kinds of GUID and some text on back of it, and create a complete alias, right? Now alias is there, but the next question that comes from the service provider is like, how can I ensure that I am controlling the exposure to my service in a good fashion, right? Even if somebody is sneaking on my shoulder and he got my alias, how can I make sure that nobody is DOSing me with like kind of connection requests? This is where the visibility comes into play, right? Service provider have all the empowerment to limit the exposure of his service. He can make a completely private service, just being shown to only his own like kind of controls, or he can make a completely public service where he want to reach out to like massive set of audience on Azure, right? Or he can even restrict it to some limited subscriptions, right? Different scenarios cover that. Cool. So now we have like given you visibility. Now the third thing is like the service providers, I mean, they don't want to be always in the business of managing the connection requests, right? So let's say like you have like 500 or 1,000 connection requests. So you will be like literally spending hours or days just managing the request and constantly watching whether somebody has requested you or not. Whereas your intent of creating this private link service was totally different, right? You wanted a service where you know like who your audience are. So with auto approval, you can set those audience in the auto approval list, and when the connection comes, that will be auto approved, right? Great. Moving on to net IP. So we are going with the promise of privacy on the consumer side. Service providers want the same promise on the service provider side. They want the ability to lock down their VNets, right, from internet. So how can we achieve that? So basically, we ask the service providers, similar to the private endpoints on the consumer side, we ask them to allocate an IP, which is a private IP. So we call it as a net IP, and use that IP to translate the source IP. So from the backend VMs, if you see the packet captures or anything, it will be looked as coming from this net IP. So basically, even if you do deny internet on and keep your like network secure, you will still be getting the traffic from different consumers, right? So we have got that. Now there is still a problem. So service providers want to also know the client IP, right? So if every traffic is coming from this net IP, right? So how will they know who is the actual client so that they are able to filter or echo their stuff? For that, we use something called TCP Proxy V2, and we are gonna get it into the next slide. Okay, so on the NAT IP, I already spoke to it. So you can see the address translation in the top right corner. Oh, sorry, top left. Address translations, I think on the left, right, bottom right. So it's an allocated IP address from the service provider, and it acts as a source IP for all the inbound traffic. So net IP has also like is very useful. Basically, I mean, for helping us ensure that the IP constraints, overlapping IP constraint does not come into play. We will like go through it later. Going on to next, TCP Proxy V2 Support. So this is a service side setting. A service provider can say like, okay, I want to receive the TCP headers, proxy headers. He has to set up like the parsing logic or like parsing so that he can read this header and extract the information. So we are already working with Nginx to get this thing into play. So you can even see a sample TLV that we are using for Azure Private Link. So with the important point here is like with TCP Proxy V2, the information that we are carrying to the destination side or the service provider side is the client IP, the actual source IP of the consumer, and the link ID of the private endpoint. So you can use this information for various different purposes such as echoing, filtering, and so on. Okay, I just want to recap whatever we have spoken so far. So with Private Link, I mean, you get a predictable IP address for configuring your policies. You can have cleaner echoes both on the consumer side and the provider side. You can route the traffic the way you want. And again, like we have went through the approval call flow. So it is totally based on the approval call flow. So you don't need to have like all the RBAC permissions or any sort of like, handles on the service to get it consumed from the consumer side. It all works with the call flow. Last, it works across AD tenants and subscriptions. So there are no such limitations. Great, let's get into some demo. So let me switch it. Okay, so here on the portal you can see like I have a couple of resource groups that are like pinned to my dashboard. So I have a resource group called Ignite PLS Demo where I will be spinning up a private link service. Similarly, I have a resource group called Private Endpoint Demo where I will be spinning up a private endpoint. And then we have another resource group in a different region. As you can see, the first two are in West Central US and the third one is in East US. So let's look into the first one first. So in the demo group, I have basically set up my service, a web service. So I have two VMs running behind an internal load balancer, so which is serving the web content. So far, I mean, it does not have a private link service here. We are going to create one. So we go to the private link hub. So as you can see, like here, you have an option to expose your service or create a new service. So we choose the subscription resource group, Ignite PLS Demo, name the service. The connectivity is a little bit slow. So as I spoke earlier, we have to select the right load balancer, which is in ILB. And it asks you to pick up the front-end IP configuration. Here we are like giving it a NAT IP. Sorry. And these are all the controls, I mean, that I've been talking about, I mean, in terms of visibility and auto approval. Let's say you want to restrict it, then it will show you the auto approval pane where you can add the subscriptions, or you can have role-based access, or you can spin as a public service. Let's do a public for now. that's it. I mean, the deployment is underway. Let's give it a second. So as you can see, I mean, in your resource group, you can see this new service, Ignite PLS, that we just created. So this is attached to the load balancer, and here is the alias that we have just discussed. So you copy the alias, and here you have a ability to go to private endpoint connections, and I'm going to create one right from here. So let's try it across different subscriptions. So here we have two options. I mean, if you have the RBAC control on the service, you can connect automatic, or if you don't have the right permissions, then you can basically connect using the alias. So you can say, please approve my connection. And here you select the virtual network where you want to deploy it. And review plus create. And create. So while it's getting created, I'm going to go back to my Ignite PLS, like on the service provider side, and we will see like the connections coming up here. Just give the deployment to finish. Yeah, you can see like the Ignite P that we just created. I mean, it's putting it into a pending state. So now as a service provider, I have the ability to approve or reject it. So let's say I want to approve it. And this is approved. Now you can go to this private endpoint. As you can see, it has like a private IP 10.0.3.5. It is connected to this Ignite PLS. Let's now see like how if we can access it. So what I'm gonna do is like log into one of the VMs in the consumer VNets. And if you go here, and use the and try to like access the service through the private IP that was created. So you can see, I mean, I'm able to access it, right? So this is so I just want to take a quick moment to go through the marketplace services. So in terms of marketplace services, all you have to do is like create your service, advertise it, and then manage the connections and manage your service. That's pretty much it. It's that simple. So you can have like the consumption experience for your marketplace services very similar to the PaaS. So we are really getting the same experience, and then the once you are a marketplace vendor on Azure, right, so you can reach all the security conscious customers. So if you are one of the marketplace services or not on the marketplace, I highly encourage you to come on the marketplace and render your services through Private Link. You can keep your service secure, and here is a wonderful quote from Snowflake. So you've been working with Snowflake for quite some time, and thanks to Snowflake for all the hard work. So I'm gonna play a quick video. Oh, sorry.
Snowflake on Azure project at Snowflake.
Can you connect to room audio? You can't hear it, right? It's okay.
I'm Polita Paulus, the engineering lead for the Snowflake on Azure project at Snowflake. Snowflake's customers include Fortune 100 companies and government agencies. Many of those customers, including banks, insurance agencies, healthcare companies, and telecoms, are deeply security conscious. These customers demand strict security and are not comfortable with having their data flow over the public internet, even if it's over TLS. They've asked for the ability to connect to Snowflake over a private IP address, ensuring their data stays within the Azure network. Azure Private Link solves this critical customer requirement by not only keeping the data over Azure networking backbone, but also providing a private IP for accessing the Snowflake service only from their VNet. Snowflake has been working closely with Microsoft for the past year to enable customers to securely connect to Snowflake completely over Azure networks, and we're excited to deliver this feature for our customers in partnership with Microsoft. We at Snowflake see Azure Private Link as a critical security offering to enable our most security-sensitive customers to unlock the value of Snowflake across their businesses with confidence that their data is secure.
Great. Okay, so with this, I am done. Thank you so much for visiting us today.